In this video, I'll be introducing the concept of the molar mass. So you might remember from my original discussion of the mole that the reason that chemists came up with it is because there were masses on the periodic table, for instance 12 for carbon, which were based on protons and neutrons, and we wanted to come up with some way so that we could use those same numbers but have it be in grams instead. And so the whole reason behind the mole is so that we have a nice, easy conversion factor getting to talking about masses of different elements so that the mass on the periodic table is still good. So the molar mass of a substance is, simply put, the mass of 1 mole of atoms or molecules. Now, the way that this works is that you can get this, the mass of 1 mole of an element, by looking at its mass on the periodic table. What we look at is called the atomic mass. All right, those are all the little numbers that are written below the elements on the periodic table. So the mass of any substance can be determined by using the periodic table. All right, so that is a tool that we're going to be using every day in here when we do this unit, is the periodic table, because we need to pull those masses off of there. Now, one thing you should do here is, as some practice, we're going to go through some different practice problems here, but if you look up iron on the periodic table, that's Fe, you'll find that it says 55.845. So we'll write that down, 55.845. Now, 1 atom of iron has a mass of 55.845 AMUs, atomic mass units, which are based on protons and neutrons. All right, but an entire mole of iron has a mass of 55.845 grams. All right, and that is the idea. So a mole of iron atoms, that is 6.02 times 10 to the 23rd iron atoms, have a mass of 55.845 grams. Typically in this class, when we go through these, we round them to the hundreds place, 2 decimal places. And so what I want you to do here is look at these 5 things, try and estimate to the 2nd decimal place, try and round it correctly to the 2nd decimal place what the mass is for each of these. So you might want to pause the video and do that, and I'll start off with the top 3. All right, calcium, if you round that correctly, you should get 40.08 grams. For neon, it's 20.18 grams. For arsenic, it's 74.92 grams. All right, now we get to H2, which is a little bit different because H2 has 2 hydrogens in it. 1 hydrogen has a mass of 1.01 grams. So 2 hydrogens, which is H2, is going to have twice that mass, so it's going to be 2.02 grams. All right, so that is what we have for a molar mass of H2, which is now a compound instead of an element. O2 is the same logic. Oxygen has a mass of 16.00 grams. If you have O2, which is 2 oxygens, it's going to have a mass of 32.00 grams. And we're going to use the same logic when we're trying to find the molar masses of these different compounds down here on the bottom. And so what we look at, for instance, for SO2, it's got sulfur in it. Sulfur has a mass of 32.07. Plus, there are 2 oxygens here. There's 1 sulfur, there's 2 oxygens. So I'm going to say 2 times 16.00 to get the 2 oxygens in there. And then if you go through and add those together, you should get 64.07 grams. H2O, on that one we've got 2 hydrogens, so 2 times 1.01, plus 1 oxygen, so plus 16.00. You add those together, and you should get 18.02 grams. For NaOH, we've got 22.99 for sodium, 16.00 for the oxygen, and 1.01 for the hydrogen. There's just one of each. We add all that together and we get 40. Now it needs to have the same level of significance as what we had, or the same level of precision. And so all of these go out to the hundredths place. And so even though it's 40, since all of these numbers out to the hundredths place, we're going to say 40.00 grams. Make sure you understand what I'm doing there in terms of sig figs, and if you don't, come in and ask me. For C6H14, that's 6 carbons and 14 hydrogens. So we take 6 times the mass of carbon, which is 12.01, plus 14 times the mass of hydrogen, which is 1.01. We add those together and we get 86.2, but again we have to go to the hundredths place, so we say 86.20 grams. All right, now I'm going to explain how we use this in a process of conversion. So similar to the problems that we were doing converting moles and atoms, or converting molecules and moles together, there's a conversion process that happens between mass and number of moles, and the conversion factor that we use is the molar mass. And so I'll kind of talk about this as we go through this first example problem, and then hopefully it'll make some amount of sense, and then there's a couple more example problems. And hopefully after you get through those, everything will be good. So number 1 says, how many moles are there in 25.3 grams of sodium chloride? So our starting point in this problem is 25.3 grams of sodium chloride, NaCl. Right? So we know that we're going to have to cancel out grams of NaCl with moles of NaCl. Oops. If we're trying to find out how many grams are in 1 mole of NaCl, that is the molar mass. And so what we've got to do is what we were doing above. All right, so what we have here is sodium is 22.99. Plus, the chlorine is 35.45. And if you add those together, you get 58.44 grams. Okay, so there are 58.44 grams in 1 mole. We use that as the conversion factor down here in our conversion table, 58.44 grams in 1 mole. In terms of the significant figures, what we look at is the 25.3 has 3 sig figs, 58.44 has 4 sig figs, and then that 1 mole is that perfect number 1 that has infinitely many sig figs. Where we do the rounding on the molar mass is in the 58.44. All right, so we've got 3 sig figs, 4 sig figs, and infinitely many, and so our answer should have 3 sig figs. Essentially, this problem is just 25.3 divided by 58.44. If you put that in your calculator, you should get 0.433 moles of NaCl. Problem number 2 here, we're starting with 1.2 moles of nitrogen dioxide. So again, you have to kind of know the naming rules, you have to remember those. We've got 1.2 moles of nitrogen dioxide, that's NO2. All right, and then we want to get out of moles of NO2. So we put it down here on the bottom to cancel out. We want to get into grams of NO2 because it says what's the mass. So again, we have to look here, nitrogen dioxide, that's NO2, which is 14.01 from the periodic table, plus 2 times 16.00. Add that together and you should get 46.01 grams for the molar mass. All right, so again, it's 46.01 grams in 1 mole. So 46.01 grams in 1 mole. You'll notice here, because we're converting the other way, that the molar mass ended up going on top and the moles was on the bottom. So in this one, 1.2 has 2 sig figs, 46.01 has 4 sig figs, and that 1 mole NO2 that has infinitely many. So we have 2 sig figs in our answer. If you put that in your calculator, you should get 55 grams of NO2. For number 3 here, it says how many moles are in 2,000 grams of silver dichromate? Now this one is problematic for a couple of reasons. One, if you look at this number here, we're only going to have 1 sig fig. The other thing is that silver dichromate is actually a relatively complicated substance. Silver dichromate, it has silver in it, which is Ag+. Because it's got a metal, we know it's ionic. That dichromate looks almost like it's covalent, but again, if we have silver, which is a metal, we know it's ionic. So you have to think, what is that dichromate? It's a polyatomic ion. It's on the back of your periodic table. It's actually Cr2O7, and it has a 2- charge on it. And so silver dichromate, if you crisscross here, is Ag2Cr2O7. That is the formula of silver dichromate. So we're going to start here with the information given. That's 2,000 grams of Ag2Cr2O7. Right, and we want to get that out of grams. What's Ag2Cr2O7? And into moles. To do that, we need to get the molar mass. Lots of things in here, all right, but we can calculate it. So it's 2 times the mass of silver, because there are 2 silvers. Silver is 107.87. Plus 2 times the mass of chromium, 2 times 52.00. Plus 7 times the mass of oxygen, so that's 7 times 16.00. Go ahead and add all those together, and what you get is 431.74 grams. So we put that 431.74 on the bottom here with the grams, and it's that many in 1 mole. So as I said, 2,000 in this problem now, 2,000 has 1 sig fig. 431.74 has 5 sig figs. All right, so our answer is only going to have 1 sig fig. So you put that in your calculator and you should get 5. It rounds to 5, and that is 5 moles of Ag2Cr2O7. As homework, there are a bunch more examples of this process. I recommend you do that and check your answers with the key that I've posted online. And as always, if you have any questions about it, make sure that you come in and ask. Don't wait until the end of the unit, because all of this is going to keep on building on itself and building on itself.